In this video, we're going to learn how to do calculations that include H3O plus concentration, OH minus concentration, as well as pH and pOH. So our first question is, calculate the concentration of H3O plus and OH minus in a 0.50 molar solution of HCl. Now, since HCl is a strong acid, we're going to assume that it fully dissociates, meaning that the concentration of H3O plus is equal to the concentration of the HCl. So that we've got right off the bat, nice and easy. Now, we're right here. If we want to get to here, our concentration of hydroxide, we just need to use the Kw equation. So we know that 0.50 molar times the concentration of hydroxide is equal to 1.0 times 10 to the negative 14th, our water constant. Of course, this only holds at 25 degrees Celsius, but we'll assume it to be 25 degrees Celsius unless told otherwise. This gives us a hydroxide concentration that is equal to 2.0 times 10 to the negative 14th molar. And we're done. Moving on. Our next problem is to calculate the H3O plus OH minus and pOH in a 0.020 molar solution of magnesium hydroxide. Now, this is interesting because we're dealing with magnesium hydroxide, MgOH2. So we need to account for the fact that there's two hydroxides per magnesium hydroxide. And that's what I'm going to start with. So here we go. We're going to say that there are 2 molar hydroxide for every 1 molar of MgOH2, which is a reasonable thing to say. So this comes to 0.040 molar. That's our concentration of OH minus. So actually, we're done with part of the problem. That's right here. And from here, well, we can get to the concentration of OH minus, or sorry, of H plus, basically doing what we previously did in reverse. We can say that concentration of H plus, H3O plus times 0.040 molar is equal to, that's going to be our Kw, which is 1.0 times 10 to the negative 14th. What we find is that our H3O plus concentration is equal to 2.5 times 10 to the negative 13th molar. So we've gone from here to here. We're also going to go from concentration of hydroxide over to pOH. And this is very straightforward. pOH is just defined as the negative log of the concentration of hydroxide, which is 0.040 molar. And pOH, therefore, is going to be equal to 0.91. I will note one thing important, and that is that with pH and pOH, the number of decimal places you should go to are equal to the sig fig. So in this case, we had 2 sig figs in our 0.040 molar solution. So we go to the hundredths in our pOH calculation. You could also get the pH from here just by taking 14 minus 0.91, and that would give you what, 13.09 would be the pH. Anyway, last problem. We're going to do this. This is going to be a 2-step problem. So a solution at 25 degrees Celsius has a pH of 3.20. Calculate its concentration of OH minus. So if we're starting at pH and we're going to OH minus, we can go in two different directions. We could either first find the pOH, which is 14 minus 3.2, and then use the kW to go, or sorry, use the antilog to go to the concentration of hydroxide. I'm actually going to use the antilog first to go from pH to concentration of H plus, and then use kW to get to hydroxide. So we have a pH equals to 3.20. So I'll use the antilog. I will say that 10 to the negative pH equals 10 to the negative 3.2. And what we get here is that the pH, or sorry, the H3O plus, which is equal to 10 to the negative pH, well, that is going to be 6.31 times 10 to the negative fourth power. So you just take 10 to the negative both sides to get from pH to concentration of H3O plus. I'll even put this in here just to make it nice and clear. Of course, this has not got us to the end. We now need to use the kW. So we will say that concentration of OH minus times 6.31 times 10 to the negative fourth is equal to our 1.0 times 10 to the negative 14th, our kW. And what we find is that OH minus is equal to 1.59 times 10 to the negative 11th molar. Now, this has 3 sig figs, and I kind of arbitrarily got to that point. I want to note that since we started with a pH that was precise to the hundredths, there are 2 digits past the decimal. There can only be 2 sig figs here, so actually this should be 1.6 times 10 to the negative 11th molar. Yeah, there we go. So that is all for this video. I hope it's been helpful to you. Please feel free to leave any questions or comments in the comment section below. Thanks for watching.